Good evening and welcome. I am the body whisperer. Pull the covers a little closer if you like. Let the pillow take the full weight of your head. Tonight, we are going somewhere most people never think to look. A quiet place tucked just behind the stomach, soft and pale and about 6 inches long, doing two completely different jobs at once, without any fuss, without any fanfare. That place is the pancreas. And the one who runs the night shift there is Pancreas Pete, the body's calm, dual-role manager, balancing digestive enzymes on one side and blood sugar hormones on the other, keeping the sleeping brain perfectly fueled until morning comes. Let your shoulders drop. Feel the weight of your arms, your legs, your hands resting still. Take one slow breath in and let it go. The eyes can close now. There is nothing you need to do, nothing to remember. Something quiet is already happening inside you, a steady, unhurried presence, working gently through the dark. Let's go meet him. Tucked just behind the stomach, soft and pale, and about the length of a hand, the pancreas has been working since before you knew the word for it. It does not announce itself. It does not ask for attention. It simply does two entirely different jobs at once, and it does them through the night with the unhurried patience of someone who has never once needed to be reminded. His name in this telling is Pancreas Pete. Pete is the body's quiet dual-role manager, not loud, not theatrical. The kind of professional who keeps the whole building running while everyone else is asleep, and who will never, in all his years, leave a note saying what he did. You wake in the morning. Blood sugar is steady. Digestion is cued and ready. Breakfast is something Pete has already prepared for, even though breakfast is hours away yet. That is Pete. That is always Pete. The organ itself sits crosswise, nestled in a curve of the small intestine called the duodenum, cradled between the stomach above and major blood vessels below. It has a wide head, a narrowing body, and a tapered tail that reaches toward the spleen. The whole structure is soft, softer than most people imagine when they picture the inside of the body. Pale and faintly granular, about the weight of a ripe pear. If you could see it in the dark of the abdomen, you would notice two things. First, the exocrine tissue, which makes up the bulk of the organ. This is the factory floor. Clusters of cells called acini, small gland units, each shaped a bit like a berry, spend their working hours manufacturing digestive enzymes. Amylase for carbohydrates, lipase for fats. A whole range of proteases for proteins. These enzymes travel down a branching duct system, the way water moves through a river and its tributaries, all of it eventually flowing into the main pancreatic duct. That duct meets the small intestine and releases its cargo where the work of breaking down a meal can actually begin. The enzymes leave the pancreas in a quiet, polite form, not yet active, not yet capable of digesting anything. They wait, a safety mechanism built into the chemistry itself. Only once they reach, the intestine do certain signals unlock them. The body designed this so that the enzymes would not, under ordinary circumstances, digest the organ that made them. Pete thought of everything. Second, scattered through the exocrine tissue like small villages in farmland are the islets of Langerhans. Perhaps 1 million of them, each one a tiny cluster of a few hundred cells. This is the endocrine side of Pete's work, a completely different job, done by completely different cells in the same organ at the same time. Beta cells in these islets make and release insulin, the hormone that lowers blood sugar by helping cells take glucose in and by telling the liver to hold back its own fuel output. Alpha cells make glucagon, which raises blood sugar by prompting the liver to release stored fuel. Delta cells make somatostatin, a quieter hormone that damps both of the others when needed, a built-in moderator on the panel. One organ, two systems, one very steady manager. Right now, as the room goes quiet and the body settles towards sleep, the digestive side of Pete's operation is mostly still. The last meal has been absorbed, the ducts are calm. Enzymes are stored in their inactive form, waiting for a morning that has not arrived yet. There is something almost peaceful about that, a factory between shifts, tools laid down neatly, every machine cool. The endocrine side, though, is not still at all. After a meal, blood sugar rises, glucose arriving from the intestine into the bloodstream. Pete notices, beta cells respond. Insulin goes out, and tissues across the body open their doors to let glucose in. The liver, that tireless night shift manager across town, stores some of the incoming fuel as glycogen, long chains of glucose, packed away for later. The signal from Pete makes that possible. As the evening moves towards sleep, the meal's glucose is absorbed, the blood sugar settles, and Pete adjusts. Insulin output falls to a low, steady baseline, not gone, but quiet. Glucagon holds a gentle presence. And together, those two hormones, in their new balance, keep the liver sending out just enough glucose to supply the brain through the hours ahead. Not a flood, just enough. The brain, even in sleep, is always asking. It does not store fuel of its own. It depends entirely on what arrives in the blood. Pete knows this. And so the whole quiet machinery of the night begins. A low, steady insulin signal, a liver listening. A slow, even trickle of glucose finding its way through the bloodstream to a brain that is already drifting through its first slow wave of sleep. Pete does not sleep the way you sleep. He does not have that option. But there is a kind of ease in what he does during these hours. No large meals arriving, no sudden glucose spikes to manage, no enzymes to rush into production. Just the long, careful work of keeping the balance. A hand on a dial, making small turns in the dark, neither too much nor too little. The body is safe in that balance. The brain is fueled. The breath is slow. The room is dark, and Pete, as always, is already on it. Somewhere outside, the night is going about its business without you. It does not need watching. You can put that down too. The last light in the kitchen has been off for a while now. The dinner dishes are done. The evening is settling into something slower, something that doesn't ask anything of anyone. And tucked behind the stomach, in that soft pale wedge of tissue no larger than a hand, Pete is doing something that almost nobody ever thinks about. He is holding a line, not pushing hard. Not pulling back, just holding the way a good thermostat holds a temperature. Not by doing something dramatic, but by making 1,000 tiny adjustments, so small they never register as adjustments at all. Here is the thing most people miss about the sleeping body. It still needs fuel. The brain, that enormously expensive organ sitting quietly behind the forehead, burns through glucose, the body's simplest sugar, at a remarkable rate, even when its owner is completely unconscious. It doesn't slow down the way a phone screen dims. It keeps running, processing, filing, and every one of those processes costs something. So the question the body has to answer, night after night, is this: how does the fuel supply stay steady when nothing is coming in? The last meal was hours ago. The intestine is quiet. The stomach has done its work. And yet the brain is not sitting in the dark wondering where its next delivery is. Something is managing this. That something is Pete. What he is doing right now is producing insulin, but only just. A low, careful baseline, steady as a drip from a well-maintained tap. Insulin, when you think of it at all, tends to be associated with meals. Blood sugar rises, insulin follows, end of story. But the story has a second act, and the second act runs all through the sleeping hours. That low baseline of insulin is doing something specific. It is restraining the liver. Liver Lisa, that large, warm chestnut brown organ tucked under the right side of the rib cage, doing roughly 500 things at once and keeping excellent track of all of them, has a standing capability. She can release glucose into the bloodstream from her own stored supply. She is very good at this. She can also manufacture glucose from scratch, out of raw materials that are not glucose at all, when supplies run low. Her storage release is called glycogen breakdown, and her manufacturing process is called gluconeogenesis, meaning the making of new glucose. Left entirely to her own devices, Lisa would be generous, perhaps too generous. The signal Pete sends, that quiet whisper of baseline insulin, tells her to be a little more measured. Not to stop, just to pace herself. We have order here, as Lisa would put it. And she does. This is the balance Pete is tending during the hours of sleep. Not silence on his end, and not a flood from Lisa's. Just a conversation, and the quietest conversations are the ones that keep things running. Now, insulin does not work alone in this arrangement. When Pete's beta cells, the insulin-producing cells nested in those small islands of tissue scattered through the pancreas, the ones called the islets of Langerhans, when those cells ease their output down through the evening, the other cells in the same islands begin to do a little more. The alpha cells, their neighbors, release glucagon. Glucagon is the signal that tells the liver to let glucose go, to open the store, to make what is needed. So as insulin falls gently through the evening, glucagon lifts gently in the other direction, and Lisa responds by releasing glucose in a measured, steady stream, just enough to keep the level where the brain needs it. What Pete is managing then is a ratio. Not just insulin, not just glucagon, the relationship between them. It is the ratio that matters, the way the relationship between the brake and the accelerator determines how a car moves, not either pedal alone. Turns out the body figured this out long before anyone had a name for either hormone. There is something almost architectural about it, this arrangement of tiny cell clusters, each one holding both types of cells close together, alpha and beta side by side, able to talk to each other directly, not just through the bloodstream. A local conversation within a global one. Researchers have found that the proximity matters, that neighboring cells influence each other by direct contact as well as by the hormones they produce. It is a short loop inside a long one. Pete knows this. He has known it longer than medicine has. And all of this happens in a space roughly the size of a kidney bean. Each islet, each little village in the farmland of the pancreas. 1 million of them, give or take, scattered through the tissue, each one holding its own small council while the rest of the organ rests in the dark. The exocrine side, the enzyme-making bulk of the pancreas, the acini and their ducts and their carefully stored, carefully inactive digestive proteins, is completely quiet. No signals from the intestine. No request for lipase or amylase. Nothing to do. It waits the way a kitchen waits after closing. Clean, stocked, ready, but not working. The endocrine side, meanwhile, does not rest. It adjusts, it listens. It holds the line. Let your breath settle now, easy and slow. The work is being done without you. It did not make the night effortless. It made it quiet. The night is deep now. Deep and still and very comfortable. There is nothing to do here, nothing to solve. You just need to be present in this quiet, in this dark. Quiet is not the same as idle. That is worth sitting with for a moment, because the resting pancreas looks, from the outside, like an organ that has simply switched off for the night. The digestive ducts are still. The exocrine tissue, all those clusters of enzyme-making cells called acini, holds its cargo without releasing it. No food has arrived. No signal has said to send anything. And yet the organ is not empty of activity. It is holding its shape, keeping its chemistry ready, maintaining the conditions under which everything can begin again the moment it is asked. There is a word for that kind of readiness. It is called tone. A muscle at rest still has tone, a background level of activation that keeps it from going completely slack. Pete has something like that. A baseline hum, not production exactly, more like the low idle of an engine that has never quite been turned off. And that baseline matters more than most people realize, because the pancreas does not wait to be surprised by food. It prepares. Here is something most people never learn about digestion. By the time a meal actually arrives in the small intestine, which is where the pancreatic enzymes do their real work, the pancreas has already been alerted. The signal went out earlier. Much earlier. It went out, in fact, before the first bite was swallowed. This early signal has a name that sounds more complicated than it is. The cephalic phase. Cephalic simply means head. It is the phase of digestion that begins in the head, in the sight of food, the smell of it, even just the thought of it. The brain registers that a meal is coming, and it sends a message downward before anything has actually been eaten. That message travels through a long, wandering nerve that runs from the brainstem all the way down through the chest and into the belly. Vagus vic, as the system might informally be understood, the vagus nerve, a pale, coiling cable of parasympathetic wiring that connects brain and gut across a remarkable distance. Vagus vic's whole register is calm. He is the nerve of rest and digest, the one whose signals say, slow the heart a little, soften the breath, prepare the gut. He has been running this line for as long as there have been bodies that eat meals, and he is never caught off guard. When Vic carries the cephalic phase signal to the pancreas, Pete listens. The exocrine side receives a gentle prompt. Get the enzymes ready. Not released, not yet, just primed. The asana cells, which make the digestive enzymes, shift from deep rest into a kind of warm standby. Amylase Amy's pancreatic cousin stir. Lipase, which will handle dietary fat, moves closer to the doors. The proteases, enzymes that will break down protein, wait in their inactive form, as they always must, because an active protease loose inside the pancreas would be a problem the organ has spent its entire evolutionary history learning to avoid. That last point is one of the quietly elegant things about this organ. The proteases, enzymes like trypsin and chymotrypsin, are powerful enough to digest protein, which means they are powerful enough to digest the tissue that made them. So the pancreas produces them in a locked form called zymogens, meaning inactive precursors that need a specific key to open. That key exists only in the small intestine. A protein called enterokinase, sitting on the surface of the intestinal lining, performs the unlocking. The enzyme arrives harmless. It is made useful only after it has left the building. That is the pancreas protecting itself from itself. Quietly, automatically, every single time. Pete knows this. All of this preparation, the cephalic signal, Vic's long message, the asana cells moving toward readiness, the zymogens holding their shape, happens before the food has crossed the stomach. The body is not reacting to a meal. It is anticipating one. And that distinction matters because a system that can only react is always a step behind. The pancreas, by being ahead, keeps digestion smooth. The enzymes are already warm when the food arrives. There is no scramble. Of course, right now, there is no meal coming. The room is dark. The stomach is at rest. Vagus vic is running a different kind of signal, the deep parasympathetic hum of sleep, the quiet instruction to maintain and restore rather than to process and move. The cephalic phase belongs to the waking hours. Through the night, it simply waits, and so the exocrine pancreas waits alongside it. Enzymes stored, duct still. Asana cells holding their quiet vigil in the dark interior of the organ, behind the stomach, tucked into the soft crook of the small intestine's first curve. There is something almost peaceful about a system that is fully capable and completely at rest at the same time. The readiness is not gone, it is just not needed yet. Morning will ask, and the answer will be there before the question is finished. Pete knows this hour, knows that the waiting is not wasted, that the stillness now is the reason the morning runs smoothly later. The exocrine side does not need activity to be doing its job. Sometimes holding a thing carefully in the dark is the whole job. It did not make the waiting empty, it made it purposeful. Let the eye stay closed. Let the face go soft. There is nothing left to look at and nothing left to decide. There is a third voice in the islets of Langerhans. Most people never hear about it. It does not make headlines the way insulin does. It does not get the dramatic storyline. It is quiet by design and quiet by preference, and it may be the most important reason Pete's night runs as smoothly as it does. The islets, those small clusters of cells scattered through the pancreas like villages in open country, hold three main types of cells. The beta cells, which release insulin. The alpha cells, which release glucagon. And a third kind, delta cells, which release a substance called somatostatin. Somatostatin. It is a long word for a short idea. Think of it as a volume knob. Not an on switch. Not an off switch, a dial. When the dial turns down, it lowers the output of both the cells beside it. Beta cells quieten a little, alpha cells quieten a little, and the whole islet settles into a more measured rhythm. Not a shutdown, just a softer hum. Here is the thing about the islets. They are not simply three independent types of cells sitting side by side. They are arranged in a very particular way. In a healthy islet, the beta cells tend to cluster in the center, and the alpha and delta cells tend to gather near the edges. That arrangement is not accidental. The cells talk to each other across short distances, not through the bloodstream, not through a nerve, but directly neighbor to neighbor through the fluid between them. It is the most local kind of conversation in the entire body. Closer than a whisper, more like a hand on a shoulder. When insulin rises, it damps the alpha cells nearby. The alpha cells release less glucagon. Less glucagon means the liver holds back a little more. That is one loop. And all the while, the delta cells keep an eye on both of them, releasing somatostatin in small pulses, trimming the edges, softening any movement that runs too far in either direction. Pete knows this. Not as a thought, but as a function. The whole system is built so that no single cell type can run unchecked. There is always a neighboring voice with a gentle word. Let your hands rest open now. There is nothing to hold. Through the sleeping hours, somatostatin does not disappear. It continues in its quiet way, pulsing out in small rhythmic waves, keeping the islet from overcorrecting. This is the part nobody explains in the standard description of blood sugar, that the system is not a simple seesaw between insulin and glucagon. There is a third weight on the bar, a moderating presence that keeps the whole assembly from rocking too hard in either direction. And here is where it becomes something worth sitting with. Somatostatin is not made only in the pancreas. It is also made in the hypothalamus, deep in the brain. The same molecule, two different addresses. The brain uses it to regulate the release of growth hormone. The gut uses it to slow digestion when a meal has been large. The pancreas uses it to moderate its own hormone output. One molecule doing quiet governance in 3 different rooms of the same house. That kind of shared language across organs is one of the things that makes the body so much stranger and more interesting than any textbook manages to convey. There is not one system for blood sugar and a separate system for digestion and a separate system for the brain. They speak the same chemical sentences. They loan each other vocabulary. The breath is easy now, slower than it was a moment ago. While you sleep, the delta cells keep their rhythm. Small pulses, measured intervals. No urgency in them, just the steady work of a system that has been doing this since long before there were words for any of it. The islets hum in their quiet villages. Beta cells hold a low, careful output. Alpha cells hold their counter signal at the ready. Delta cells sit at the edge of both, offering the same small correction they have always offered. It is the kind of balance that does not announce itself. You do not feel it. The brain does not register it as anything remarkable. The blood moves through the capillaries that lace the islets, and those capillaries are dense, far denser than in most tissues, because the hormones released here need to reach the bloodstream immediately, and the molecules pass into the current and travel outward, and the liver listens, and the tissues respond, and nothing makes a sound. Liver Lisa, on the far end of all those signals, receives each message with the same steady professionalism she brings to everything. When insulin says hold back, she holds back. When glucagon says release, she measures out the fuel and sends it. She is not passive in this. She has her own glucose sensors, her own internal accounting. But she defers to the islets. She has learned that Pete's signals are reliable. She would not use the word trust. She would say, the signals arrive and she acts on them. That is sufficient. Pete knows this hour. The delta cells and their soft governance, the careful architecture of the islet, the fact that balance here is not the absence of movement, but the presence of 3 overlapping moderating forces, all of it running without a single conscious thought from the brain above. The night does not need to be managed from the top down. It manages from within. It did not make the system complicated. It made it resilient. Notice the weight of your head on the pillow. Heavier than you thought. Let it be that heavy. Resilience in a body does not look like strength. It looks like subtlety. The kind of subtlety that hums at a frequency too low to notice, like a furnace in a basement, keeping every room warm without ever announcing itself. That is what Pete manages through the sleeping hours, not a series of bold adjustments, but a continuous, almost imperceptible negotiation between what the blood has and what it needs. Here is the thing about baseline insulin. Most people, when they think of insulin at all, think of it as the response to eating. The meal arrives, the blood fills with glucose, and the pancreas releases insulin to handle it. That story is true, but it is only half of it. Even when no food has arrived for hours, even deep in the sleeping hours, when the small intestine is quiet and the stomach has long since emptied, the beta cells still release insulin. Not in great waves, just a slow, low, continuous trickle, quiet as a dripping tap in another room. Enough to matter enormously. What it does is this. The liver, left entirely to its own devices, would release glucose at a rate determined by its own internal accounting. It has the fuel. It has the machinery stored sugar called glycogen sitting in its cells ready to be broken down, and the ability to build new glucose from scratch, pulling in amino acids and other raw materials in a process called gluconeogenesis, meaning the making of new sugar from non-sugar sources. Lisa is very good at both. She does not require much prompting, but without any insulin at all, the liver's fuel output would run a little high. Not dramatically. Just a shade more than the sleeping brain requires. And a shade more, compounded across the hours of a night's sleep, would shift the balance. The blood would carry a little too much glucose. Not by a number that would feel like anything. Just enough to matter at the level of chemistry. The baseline trickle of insulin prevents that. It sits in the blood at a low, steady concentration, and it tells the liver, quietly, without drama, to hold back a little. Not to stop, not even to slow dramatically. Just to moderate, to calibrate. Liver Lisa, at the other end of that signal, receives it the way a professional receives a memo. Promptly, without complaint, without the need for it to be repeated. She would still appreciate a thank you note. So what the body has, through the sleeping hours, is a loop. Pete releases a low level of insulin. Lisa reads the signal and adjusts her glucose output. That output enters the blood. Pete's beta cells sense the resulting glucose level. They are exquisitely sensitive to blood glucose, responding in proportion to what they detect, and they adjust their insulin release accordingly. Not a single event. A loop. Continuous, automatic, running without any conscious instruction from anywhere. Pete knows through these quiet hours, knows that the loop runs best when it is never pushed to extremes. The elegant design of it is that the beta cell does not need a set of rules. It does not consult a chart. It simply responds to the glucose concentration it is bathed in, increasing output when that concentration rises, easing back when it falls. The cell is the sensor and the responder at once. One mechanism, two jobs. This kind of system, where the output of a process feeds back to regulate the process itself, is called a feedback loop. And it is one of the oldest ideas in biology, long predating any person who thought to name it. The body arrived at feedback loops before language did. It has been running them without interruption since well before any of its parts knew what a loop was. And quietly, alongside the hormone conversation, something else is also happening. The pancreatic duct, the long channel that runs through Pete's exocrine tissue like a spine, gathering enzyme-rich fluid from the small sacs called acini, is essentially still. The acini themselves are resting. The enzymes they hold, packed into those small storage pods called zymogen granules, are waiting. They have been waiting since the last meal made its way through. They will wait until morning, or until a meal calls them. But the duct is not dead. It continues to secrete a slow stream of fluid, water and bicarbonate, meaning a mildly alkaline solution, even during sleep. Not enough to do much. Just enough to keep the channel open, the environment gently buffered, the tissue moist and maintained. A small gesture of readiness. The way a good kitchen keeps a low flame under a stock pot long after service has ended. Glucose Gloria, meanwhile, moves through the bloodstream in her unhurried rounds. She rises very gently when the liver ships a little more out. She eases when Pete's insulin asks Lisa to pull back. She does not accumulate. She does not vanish. She stays throughout the sleeping hours, within a range narrow enough to keep the brain comfortable and wide enough to reflect the normal rhythm of a body at rest. She is exactly where she needs to be. She would simply like everyone to notice how reliable that is. The loop is not a machine running on fixed settings. It is a conversation sustained across the hours of sleep between a soft, pale organ and the large, warm liver that listens to it, each adjusting to the other, neither in charge exactly, both essential. It did not make the night simpler. It made it steady. This is the easiest part of the whole day. Nothing to carry, nothing to finish, only rest and the quiet dark. Steady is not the same as still. That is worth sitting with for a moment. A steady hand on a dial is a hand that is moving constantly in very small increments, nudging left when the number drifts too high, nudging right when it drifts too low. The hand never stops. It just never makes a fuss about it either. Pete's hand has been on that dial all through the sleeping hours. And somewhere in the deepest part of the night, not at a fixed minute on a clock, but at a place in the body's own rhythm, something shifts. The body has a clock of its own, not a metaphor. A real molecular timepiece running inside nearly every cell, built from interlocking proteins that switch each other on and off in a cycle that lasts roughly 24 hours. This internal clock is called the circadian rhythm, from the Latin for about a day, and it does not wait for the sun to come up before it starts preparing for morning. It starts preparing hours ahead. Around the time sleep is deepest, two hormones begin to rise. Cortisol, the body's long-range readiness signal, starts climbing from a low nighttime floor. Growth hormone, which handles repair, renewal, and the movement of fuel between tissues, peaks in a single large pulse not long after sleep begins, then settles. Both of these are part of the body's ordinary rhythm. They happen every night, in every healthy body, without any particular trigger. They are the body's way of saying, morning is coming, start getting ready. Here is the thing about getting ready, though. Cortisol and growth hormone, as they rise, gently reduce how sensitive the body's tissues are to insulin. Not dramatically, not suddenly. Just a small, gradual shift in the way muscle and fat respond to the signal Pete sends. The cells become, in a mild sense, less eager to open the door when insulin knocks. This is called insulin resistance when it is a persistent condition, but what happens in the pre-morning hours is simply its temporary, ordinary, built-in version, a feature of the circadian system, not a fault. The body is routing fuel toward the brain at the moment when sleep is at its lightest and morning is closest. It is a kind of preparation Pete notices. He notices the way a good manager notices when the workload quietly increases, not with alarm, but with a measured response. The beta cells, reading the slight uptick in blood glucose that comes when tissues are a little less responsive, release a little more insulin. Not a large pulse, not an announcement. Just a gentle upward adjustment to the baseline trickle that has been running all along. The result is that blood glucose, glucose gloria, moving through the bloodstream in a steady hexagonal way, just wanting to be useful, stays within the same narrow, familiar range she has occupied all night. The adjustment is invisible from the outside. From the inside, it is a small masterpiece of timing. This pre-morning adjustment even has a name. It is called the dawn phenomenon, meaning the natural rise in insulin demand that accompanies the body's circadian preparation for waking. In a body where the feedback loop is working, the phenomenon is self-correcting before it becomes noticeable. Pete raises his output. Liver Lisa, receiving the slightly stronger signal, moderates her glucose release accordingly. Glucose Gloria keeps her steady course. Pete knows this hour, knows it the way a lighthouse keeper knows the tide chart. Not because anything needs rescuing, but because the pattern is worth understanding. The remarkable thing is that Pete is doing this without being asked. There is no alarm, no message from the brain. The beta cells themselves are reading the local environment, the glucose level in the blood passing through the islets, and adjusting their output in real time. This is what makes the islets of Langerhans so quietly extraordinary. They are not waiting for instructions from above. They are sensing and responding on their own, at the cellular level, one islet at a time. Roughly 1 million of those small clusters are scattered through the pancreas, each one reading the same signal and contributing its small share to the answer. No single islet carries the whole load. The response is distributed, like a choir where every voice matters, but no one voice does all the work. And the exocrine side of the pancreas, The vast, quiet machinery of ducts and acidae that handles digestion sleeps through all of this. The enzymes are still locked. The main duct is still at rest. The bicarbonate trickle continues at its minimum, keeping the internal environment gentle and balanced. The digestive side does not need to know about the dawn phenomenon. That is not its department. Two jobs, two systems, one organ. The division is clean in biology, but in practice the two sides share a neighborhood. The blood supply that feeds the eyelids passes through the exocrine tissue on its way out, which means that the hormones Pete's eyelids release actually wash over the surrounding digestive tissue before entering the general circulation. Whether that local exposure matters for the exocrine side's own behavior is something researchers are still working out. For now, it is enough to notice that the two worlds are closer than a diagram suggests. Let the breath be easy now. There is nothing to follow here, but the quiet logic of the body doing what it has always known how to do. The adjustment was not dramatic. It did not need to be. Let the back settle into the mattress. Let it take your weight completely. It has been waiting all day to do that. There is a side of Pete that has been perfectly still for hours now. Not idle, not switched off. Just waiting the way a skilled craftsman waits between jobs. Tools set down neatly, workspace clean, everything in its proper place. The exocrine pancreas, which makes up the great bulk of the organ, has been in exactly this state since the evening meal finished its long passage through the small intestine. And there is a particular beauty to the way it rests. Most of Pete's mass is made up of clusters of secretory cells arranged in small tight groups like tiny bunches of grapes called acidae, the Latin word for grapes, as it happens, which seems right. Each acinus is a little production unit, ringing a central hollow space the way workers ring a shared drain. During a meal, those workers are extraordinarily busy. Enzymes pour from every cell, down into the hollow center, then along collecting channels, then into the main pancreatic duct, and finally out into the small intestine where the real work begins. But right now, the collecting channels are quiet. The duct carries only its thin trickle of bicarbonate fluid, protective, slightly alkaline, keeping the inner walls from drying, and nothing else moves. The enzymes themselves are still being made, slowly and stored. That storage is the part worth pausing on. The acinar cells do not store active enzymes. That would be far too risky. Instead, they package each enzyme in a locked, folded form, a precursor version called a zymogen, meaning a dormant enzyme waiting for a signal to open. The cell wraps the zymogen in a membrane, tucks it into a small storage pocket called a zymogen granule, and leaves it there until a meal arrives and the signal comes. Think of it like a letter sealed in an envelope. The words are all there. The message is complete. It simply will not be read until someone opens it, and that opening only happens in the right place, the small intestine, when the right conditions are met. The enzyme that breaks open proteases, the protein-digesting family, is called enterokinase, and it lives only in the lining of the small intestine, not in the pancreas itself. Pete does not carry the key to his own locks. The intestine holds it. This means that even if a zymogen granule were to rupture inside the pancreas, the enzyme inside would remain inert. There is nothing around to open it. This is not an accident. It is a design refined across hundreds of millions of years, and it is one of the more elegant safety arrangements in the entire digestive system. The organ that makes the most powerful protein-dissolving agents in the body keeps them in a form that cannot dissolve anything, not until they arrive at exactly the right destination. Amylase Amy, for her part, is a small exception to this rule. Amylase, the starch-splitting enzyme that Amy represents, does not need to be kept locked up in the same way because amylase does not digest living tissue. Starch is plant material, not animal tissue, and the body's own cells are not made of starch. So amylase can be stored in its active form without the same concern. Amy's pancreatic cousins sit ready in their granules, already switched on, simply waiting for the call. She considers this entirely fair, she would say. She earned the early access. The pancreatic duct itself, the main channel running the length of the organ like a hallway down a long building, is also quietly resting. During a meal, this duct carries a remarkable flow, a bicarbonate-rich fluid that neutralizes the stomach acid arriving in the small intestine, protecting the intestinal lining and creating the mildly alkaline environment the enzymes need to work. Lipase, the fat-splitting enzyme, is particularly particular about this. It simply will not function in an acidic environment. The bicarbonate is not incidental to digestion. It is the condition that makes digestion possible. Right now, though, the duct produces only a whisper of that fluid, just enough to keep the channel moist and open, a maintenance trickle, nothing more. What strikes you, if you sit with Pete long enough in the dark, is how much of the organ's design is about restraint, about not acting until the moment is exactly right. The zymogens wait. The granules hold. The duct carries the minimum. The acids do not pour unless called upon. And all of this is coordinated, not by the pancreas alone, but by signals arriving from the vagus nerve, from the gut lining, from the sight and smell of food that vagus Vic anticipates well before a single bite is swallowed. The exocrine system does not improvise. It responds, and when there is nothing to respond to, it is content to wait. There is something quietly instructive about that. The body runs best when its systems are not all running at once. The sleeping hours are the exocrine pancreas's version of what the brain does when it sets down the day's worry. Not absence, but the steady, patient presence of something that knows its moment has not yet come. Pete knows this in the particular way that a body knows things. Not in words, but in the steady holding of position. The granules waiting in their cells, the duct moving its slow trickle. The whole exocrine side, arranged and ready for a morning still hours away. It was not waiting without purpose. It was waiting as purpose. Everything is quieter than it was a moment ago. Even the small sounds have gone soft around the edges. There is a kind of conversation that happens without anyone picking up a phone. Deep inside Pete, in those small clusters of cells scattered through the tissue like villages in farmland, the beta cells and alpha cells and delta cells are not simply receiving orders from above and carrying them out. They are talking to each other, directly, sideways, across the narrow space between one cell and the next. This kind of local cell-to-cell signaling, biologists call it paracrine communication, meaning signals passed between neighboring cells rather than shipped through the bloodstream, is one of the quieter wonders of the islets of Langerhans. The hormones released here do not always have to travel far to do their work. Sometimes the neighbor is the point. Here is how it works. A beta cell releases insulin. That insulin does not only travel outward into the blood. Some of it lingers locally, reaching the alpha cells right next door. And insulin, as it turns out, is one of the signals that tells alpha cells to ease back on glucagon. So the beta cell is not just talking to the liver. It is also, in a quieter voice, speaking to the cell beside it. The alpha cell, for its part, returns the favor. Glucagon released by an alpha cell can reach neighboring beta cells and nudge them toward a little more insulin output. A quiet prompt, a gentle check. The two populations moderate each other without any central authority calling the shots. And the delta cells sit in the middle of all this, releasing somatostatin into that same small local space. A short-range moderating signal that quiets both its neighbors at once when things have gone far enough in either direction. Not too much insulin, not too much glucagon. The delta cell is the one that says, "That will do for now." Pete knows this. What makes the islet design so worth pausing over is how self-contained it is. Each islet, and there are roughly 1 million of them, remember, scattered through the whole organ, carries its own small version of this conversation. Beta cells, alpha cells, delta cells, arranged in a loose cluster, each type aware of the others through those short paracrine signals. The whole organ does not have to agree at once. Each village manages its own affairs. And when 1 million small conversations all arrive at roughly the same answer, that answer is the blood glucose level the sleeping brain wakes up to. It is a distributed system, in the way that a well-run city is distributed. No single office holds all the information. The information lives everywhere, in the gaps between cells, in the small signals passing back and forth across distances measured in micrometers. A micrometer being roughly 1/100th the width of a human hair. The precision of the outcome comes not from a single commanding voice, but from 1 million local agreements. This matters more through the sleeping hours than it might seem at first. When nothing is arriving from the intestine, no meal, no glucose surge, no incoming signal telling the system to prepare for a feast, the islets are still working. Not at full volume. Not in urgent response to anything, but the local conversation is continuous. A slow, low murmur of paracrine signals, each cell aware of its neighbors, each adjustment small, each answer provisional until the next one arrives. It is the biological version of a night watchman making rounds. Not because anything is happening, because staying aware is the job itself. Amylase Amy, resting in the exocrine tissue nearby, has no part in this conversation. Her world is enzymes and starches and the satisfying snap of a glycosidic bond, the chemical link that holds sugar chains together. But she is aware, in the vague way that any working tissue is aware of the larger system around it, that something is happening in the islets even now. She would describe it as her cousins keeping the lights on. She is not wrong. And liver Lisa, far away in the upper right of the abdomen, the liver being the body's largest internal organ, a smooth chestnut-lobed structure responsible for more jobs than most people can name. Lisa receives the result of all that murmuring. Not the murmur itself, just the conclusion, the agreed-upon insulin to glucagon ratio that tells her how much glucose to send into the blood and how much to hold in reserve as stored glycogen. She acts on it without needing to know the details of how it was decided. This is, in fact, a good description of most of what Pete does. The decision-making is distributed, local, paracrine. The output is singular, stable, and legible to the organs that depend on it. Glucose Gloria, drifting through the bloodstream in a quiet hexagonal shape, is the evidence that the system is working. She stays within her narrow range, not high, not low, just present in the right quantity, because a million small conversations somewhere inside Pete are continuously, without drama, agreeing on the right answer. Nobody broadcasts this. There is no announcement. The body simply continues. Pete knows this hour. The eyelid was not designed to centralize. It was designed to distribute, so that the answer would always be nearby, in whatever part of the organ was closest to the need. Not one wise cell making all the calls. A million small cells, each doing a little, each listening to the one beside it. It did not make the night more efficient, it made it resilient. The room is dark, and the dark is kind. Sleep is not something you reach for. It comes and finds you. Resilience is a word that gets used a lot. It gets attached to cities, to people, to morning routines. But in the body, it has a quieter meaning. It means the system keeps working when one piece shifts, when the signal is a little late, when the demand is a little higher, when the night is longer than expected. The islets do not fail if one cluster is slower than the others. The whole network holds. And somewhere inside all of that, inside this 6-inch organ lying behind the stomach in the dark, there is a detail that most people never hear about. The pancreas is not one kind of tissue wearing two hats. It is genuinely two different organs, grown together, sharing a space so intimate they share a blood supply. Here is what that means in practice. The exocrine tissue, the part that makes digestive enzymes, makes up something close to 85% of the organ's mass. Most of Pete is dedicated to that job. The asana cells, the ducts, the zymogen granules all packed and waiting. That is the bulk of him. It is the dominant architecture. If you looked at a cross-section of the pancreas, that is most of what you would see. But laced through it, like small islands in a wide sea, which is exactly what their name suggests. Islets of Langerhans meaning small islands. The endocrine clusters are everywhere. Not gathered in one corner, not separated by a wall, scattered throughout, surrounded on all sides by exocrine tissue, sharing the same capillaries that thread through the whole organ. And this matters more than it might seem, because those shared capillaries carry blood through both systems. Insulin released by a beta cell does not have to travel far to reach the local exocrine tissue. It is already there. And it turns out that the exocrine pancreas is itself sensitive to the hormones its endocrine neighbors are releasing. Insulin, drifting through the shared blood supply, touches the asana cells directly. It influences how those cells behave, how ready they are, how responsive to the next meal. The two systems are not just living in the same building. They are reading each other's mail. Pete knows this. Through the sleeping hours, while the exocrine side sits in its purposeful quiet, enzymes stored, ducts carrying only a slow trickle of bicarbonate, the whole digestive apparatus in warm standby, the endocrine side is working. And its work reaches across the internal boundary. The insulin circulating through Pete's own tissue is not only a message to liver Lisa. It is a message to the asana cells as well. A quiet note sent through shared blood that says, the body is in a resting state. There is no need to prepare a full enzyme release. Hold, the asana cells are already holding. But the signal confirms it. And there is something almost elegant in that, the endocrine system reinforcing what the exocrine system is already doing, not through a separate command, but through the same small capillaries they both depend on. There is a word for this kind of signaling. When a hormone acts on cells very close to where it was released, not traveling through the bloodstream to a distant organ, but touching neighbors right there in the same tissue, it is called paracrine signaling. The islets do this internally, as the previous hour showed, but they also do it outward, into the tissue surrounding them, into the cells that share their blood supply. It is a local conversation in a very small room. Vagus Vic, the wandering nerve that carries the gut-brain line both ways, is quiet right now. His parasympathetic signals, the ones that tell Pete a meal is coming, the cephalic phase that primes the exocrine system before a single bite has arrived. Those lines are not active while the body sleeps. Vic is present. The line is always open, as he would say, but he is not transmitting. The signals from the brainstem are turned low, and without that parasympathetic nudge, the asana cells have no instruction to ramp up. So the local endocrine signal fills a role that the nervous system has stepped back from. The insulin is there, the tissue reads it, the system stays coherent. Glucose Gloria, meanwhile, remains in her narrow band, not drifting high enough to prompt a strong beta cell response, not drifting low enough to prompt a glucagon reply from the alpha cells. She is in transit, as she always is, moving through capillaries, slipping into cells that need her, cycling steadily through the liver's careful accounting. Liver Lisa is keeping the output measured, because Pete's baseline insulin is keeping Liver Lisa's hand steady. All of it connected, all of it local. All of it happening in an organ smaller than a hand. The plain fact is that the pancreas does not have the luxury of separating its two jobs into different buildings. It never had that option. Evolution did not clean up the arrangement. It left both systems tangled together, sharing walls, sharing blood, close enough that their signals inevitably overlap. What looked like a design constraint turned into something more useful than anyone might have planned. The endocrine system influences the exocrine system from inside the same tissue. The whole organ becomes a single, cross-stalking network. It did not make the organ simpler, it made it continuous. Let the jaw unclench. Let the space between the eyebrows go smooth. Small places hold the day longest. The pancreas does not have two departments with a wall between them. It has two systems woven through the same soft tissue, sharing the same blood, the same nerves, the same few inches of space behind the stomach. That closeness is not accidental. It is, in its own quiet way, the whole point. Here is something most textbooks move past too quickly. The islets of Langerhans, those small villages of endocrine tissue scattered through Pete's body, are not uniformly distributed. They cluster more densely toward the tail of the organ, the narrow end that tucks toward the spleen. The head, the wider end that nestles against the curve of the small intestine, carries more exocrine tissue, more asana cells, more enzyme-making machinery. Two different concentrations, one organ. That arrangement is not random either. The tail-end islets are well positioned to release their hormones into blood vessels that flow onward through the body. The head-end asana cells are positioned close to the duct that empties into the small intestine, exactly where digestion happens. Form following function. Pete's own geography is a kind of logic, written in tissue instead of words. While you sleep, the head is quiet. The asana cells have done their evening work. Enzymes sit packed into granules, still folded in their inactive forms, waiting. The duct carries only its slow bicarbonate trickle, just enough fluid to keep things from going stagnant, not enough to signal that anything is open for business. The head of the organ rests the way a kitchen rests between services. Clean, stocked, doors closed, the tail is another matter. In the tail, the islets go on working. Beta cells release their low, steady measure of insulin into the capillaries. Alpha cells contribute their glucagon, measured and moderate. Delta cells keep their somatostatin murmur going, quieting any excess before it can build. The paracrine conversation between neighboring cells continues as it has all night, local and self-correcting and unhurried. Pete knows this, that the two ends of his own body are doing entirely different things at the same moment, and that neither end needs to announce itself to the other. The blood supply connects them. The hormones move. The information travels without a memo. What is worth pausing on is the way these two systems, exocrine and endocrine, actually developed. They grew from the same original tissue in early life, the same embryonic bud that folded and differentiated into the full adult organ. Early in development, cells that would become asana cells and cells that would become islet cells were neighbors making the same decision. Which way to go? Some went one way, some went the other. The organ that resulted carries both lineages, and they have been sharing space ever since. That shared origin is part of why the systems are so coherent. Insulin released by beta cells does not just travel to the liver and the muscles and the fat tissue. A portion of it bathes the nearby asana cells directly, those enzyme-making exocrine cells in the same neighborhood. Insulin at those concentrations actually supports the asana cell's readiness to make and store enzymes. It is a signal that says, conditions are stable, keep your preparations, the morning will come. And the asana cells, in their resting state, do exactly that. They synthesize new enzyme proteins slowly through the night, replenishing the granule stores that the evening meal drew down. They are not idle, they are restocking. The kind of quiet preparation that happens best when no one is asking for output. Amylase Amy would recognize this rhythm immediately. Her pancreatic cousins, the amylase molecules packed into asana granules, spend the sleeping hours being made, folded, packed away. Ready, they do not chafe at the waiting. Waiting is the other half of readiness. Liver Lisa, for her part, has been receiving Pete's insulin signal all night without complaint. When insulin is present, even at low levels, she holds back. She does not release more glucose than the brain and the rest of the body are asking for. She matches supply to need, the way any good night manager balances the books by what is actually on the floor, not by what theoretically could be. The result, through the sleeping hours, is a kind of metabolic quiet that is easy to miss because nothing about it announces itself. Blood glucose holds within its narrow range. The liver releases fuel in a slow, metered stream. Pete's islets adjust their ratio, more insulin, less glucagon. Or the other way, in increments too small to measure without instruments. The exocrine side rests. The endocrine side tends, and the whole organ, head to tail, does this as one structure, not as two systems that happen to share an address. As one organ that learned, long ago, to speak two different languages and translate between them without stopping. That is what the shared blood supply does. That is what the paracrine signals do. That is what the anatomical arrangement, tail toward the endocrine work, head toward the digestive outlet, quietly accomplishes. It did not make the organ more complicated, it made it whole. Let your shoulders drop a little further. Let the back of your neck soften. The pillow is doing the work now, not you. There is a river inside Pete that nobody talks about. Not the blood, not the hormones. Something else entirely, a slow, pale current of fluid that moves through the pancreatic duct and carries something remarkably humble. Bicarbonate, just ordinary bicarbonate, the same chemistry that turns baking soda into bubbles. And yet, through the sleeping hours, it is one of the quieter acts of maintenance happening inside the body, without any instruction from you at all. Here is what it does, and why it matters. The digestive enzymes that the exocrine pancreas makes, amylase for starch, lipase for fat, the proteases that dismantle protein, are strong. Genuinely strong. Left to themselves in an acidic environment, they will be far too ready to act on whatever tissue happened to be nearby. The stomach, doing its own work, sends a fairly acidic stream down into the small intestine. And the small intestine, which is where those enzymes do their work, cannot simply sit in acid and function well. Something has to adjust the chemistry first. That something is bicarbonate. Pete's ductal cells, the cells that line the channels leading from the asana cells out to the main pancreatic duct, are responsible for making and releasing this fluid. It is not an enzyme. It is not a hormone. It is a buffer, meaning it neutralizes acid and brings the local environment toward a more workable, gentler chemistry. When food is moving through the system during the day, this release is substantial. The ducts pour out a considerable volume, and the result is that the acidic stomach contents are met, buffered, and calmed before the enzymes get to work. The enzymes can then act without burning the very surface they are meant to help. It is a quiet piece of engineering, the kind that gets no credit. During the sleeping hours, the ductal cells reduce this output to almost nothing. No food is coming. No acid is arriving from the stomach in any meaningful amount. The whole buffering system idles. But it does not stop entirely. There is always a faint, slow trickle, enough to keep the duct itself patterned, meaning open and clear, the way you might leave a slow drip in a pipe during a cold night to keep it from seizing up. Not production, just maintenance. Vagus Vic. That long wandering nerve whose cable runs from brainstem to gut and carries the parasympathetic signal that says a meal is on its way, is quiet now. Vic handles roughly 80% of the traffic on the gut-brain line, and most of that traffic runs upward, gut informing brain, not the other way around. During sleep, that conversation slows. The brain is not sending mealtime signals. And so Vic rests, his line still open, his signal simply low. Without that cephalic phase signal, the anticipatory message that normally primes Pete before food even arrives, the ductal cells have no instruction to ramp up. They maintain, they wait. Pete knows this hour. What is interesting is that the ductal cells and the asana cells, though they do different jobs, are responding to the same set of signals. Hormones called cholecystokinin and secretin, released by the small intestine's own lining when food arrives, are what normally drive both enzyme secretion from asana cells and bicarbonate secretion from ductal cells. One organ, one arriving signal, two coordinated responses. Through the sleeping hours, those intestinal hormones are not being released in any significant amount, because there is nothing in the intestine prompting them. The signal chain is quiet at its source, so the river rests, And resting is precisely the right word, because it implies that the capacity is still there. The ductal cells have not lost the ability to produce bicarbonate. The asana cells have not lost their zymogen stores. In fact, as the previous hours have suggested, they have been quietly restocking them. The whole exocrine system sits the way a skilled worker sits between tasks. Calm, capable, not idle in any wasted sense. Ready is not the same as working. And through the sleeping hours, the exocrine pancreas is thoroughly, efficiently ready. Amylase Amy, whose job begins the moment starch enters the mouth, that is where her salivary cousins clock in, would appreciate the distinction. Her pancreatic relatives, the ones whose working address is Pete himself, are not off the clock. They are pre-shift, enzymes properly stored, granules full, duct maintained. The machinery is clean and oiled, and waiting for a morning signal that has not yet arrived. Amy finds this admirable. She has always thought the pancreatic side of the family takes preparation seriously. There is something worth sitting with in all of this. The bicarbonate system exists entirely to protect the small intestine from enzymes that exist entirely to protect the body from undigested food. Layer under layer, each one a response to the one before it, each one doing its small, specific job so that nothing downstream is overwhelmed. Not dramatic, not visible from the outside. Just a long chain of quiet chemistry humming along in the dark. The ductal cells do not know they are part of something elegant. They simply release bicarbonate when the signal arrives and hold back when it does not. That is all they are asked to do. It did not make the resting body simpler. It made it steady. Warmth is spreading through the shoulders, down the arms, into the hands, slow and even like heat through a room. There is a thing that happens in the pancreas while the rest of the body sleeps, and it has nothing to do with urgency. It has to do with listening. Pete has always been a good listener. The two sides of him, the exocrine side that makes digestive enzymes and the endocrine side that makes hormones, are often described as if they live in separate apartments. Same building, different functions, nodding politely in the hallway. And in a rough sketch, that is not wrong, but it misses something real. It misses the fact that the signals running through Pete's tissue are not compartmentalized. They move freely. They land wherever there is a receptor willing to receive them. Here is a quiet example of that. Insulin, the hormone Pete's beta cells release to signal tissues to take up glucose from the blood, does not disappear at the boundary between endocrine and exocrine tissue. It keeps moving. And the asana cells, those exocrine workers that make digestive enzymes and store them in their compact zymogen granules, have insulin receptors. They can hear that signal. They respond to it. What insulin seems to say to an asana cell is something like, conditions are favorable, stay prepared, do not go cold. So through the sleeping hours, when Pete's beta cells are maintaining that low continuous trickle of baseline insulin, the same trickle that tells liver Lisa to moderate her glucose output, those same molecules are also touching the exocrine tissue. Not with force, not with instruction, more like a draft of warm air under a door. Enough to keep things from going entirely still. Amelay's Amy, if she were narrating this moment, would probably call it a family communication. She is fond of that framing. Her pancreatic cousins, the amylase stored in asana cells, her equivalents in the exocrine organ, are sitting in their granules in the dark, and insulin is one of the signals that helps keep the conditions around them stable. She finds this satisfying. The whole organ, she would say, is a family business. And insulin is apparently on the group message. It is a small thing. But small things, done consistently through every night of a life, are how the body stays organized across decades. There is a related mechanism worth pausing on, and it involves the way the pancreas handles its own local blood flow. The islets of Langerhans, those roughly 1 million small endocrine clusters scattered through the organ, receive a disproportionately large share of the blood that moves through the pancreas. Somewhere between 10 and 20% of the organ's blood flow goes to tissue that makes up only 1 or 2% of its mass. The islets are heavily perfused, meaning the blood moves through them richly and continuously, because they need to sense glucose levels in real time, and sensing requires contact. But the blood does not simply arrive at the islets and leave. It flows onward. From the islets, blood moves into the capillaries that serve the surrounding exocrine tissue, which means the asana cells are bathed in blood that has already passed through the islets, blood that carries whatever the islets have just released, including insulin, including glucagon, including somatostatin. This arrangement has a name, the insulus in our portal system, meaning the blood path from islet to asana cell, and it means the exocrine pancreas is continuously downstream of the endocrine pancreas. Every signal the islets release reaches the asana cells first, before it reaches the general circulation. The asana cells get the message faster than the rest of the body does. And so when Pete's beta cells are releasing their low nighttime baseline of insulin, the asana cells nearby are among the very first to receive it. They are not waiting on a memo. They are in the room. Through the sleeping hours, this matters in a particular way. The asana cells are restocking their zymogen granules, quietly resynthesizing enzyme proteins, loading them into new storage packets, preparing for the digestion that morning will eventually ask for. That resynthesis takes energy and resources. And insulin is part of what tells a cell that resources are available, that it is appropriate to build rather than conserve. Vagus Vic, for his part, is quiet during all of this. His cephalic phase signals, the pre-meal parasympathetic instructions that trigger a burst of enzyme secretion, are not running. The body is asleep. The brain is not anticipating a meal. Vic is not on active duty, but his baseline tone, the low hum of parasympathetic activity that persists even in sleep, contributes to the general stability of the gland. A resting organ is not a switched-off organ. There is always some background signal maintaining the readiness of the tissue. Glucose Gloria, meanwhile, moves through the blood in her usual quiet hexagonal way, staying within a narrow range, absorbed where she is needed, passed by where she is not. She is not dramatic about any of this. She simply keeps moving. The brain is taking her in steadily. The body at rest uses her at a slower rate than it would while walking or working. That reduced demand is part of why the balance holds so easily through the sleeping hours. Less is being asked of the whole system, and so the whole system can afford to be gentle with itself. Pete knows this in the way an organ knows things. Not with language, but with chemistry. The local signals are steady. The feedback is running. The two sides of him are not separate systems sharing a building. They are one organ listening to itself. It did not make the night more elegant. It made it whole. Nothing is required of you now. Not thinking, not planning, not remembering. All of it can wait until morning. The body has grown very still. The breath is slow now. The muscles have let go. The weight of everything settles a little further into the mattress, and the room is as dark as it is going to get. And inside, tucked behind the stomach, Pancreas Pete keeps his quiet watch. He has been here all along. He will be here until morning. He does not need to be reminded. He does not need to be thanked. He simply keeps going, the way a good manager does, not with noise, but with steadiness. The eyelids are still, not silent, never quite silent, but still in the way a room is still when someone is reading in the corner. There is activity there. There is attention there. But it is soft. It is unhurried. The beta cells are doing what they have done all night, releasing a low, careful thread of insulin, just enough into the blood, just enough. And liver Lisa, on the other end of that signal, is listening. She is always listening. That is what she does. When Pete says a little less, Lisa holds back a little. When Pete says a little more, Lisa opens the gate. The two of them have been trading these quiet adjustments for hours now, and neither one has had to raise its voice. We have order here. Glucose Gloria moves through the blood at the same unhurried pace she has maintained since sleep began. She is not waiting for anything. She does not need to be. The brain is taking what it needs, slowly, steadily, and she is there to give it. That is enough. That has always been enough. Just let her in, and she goes. Somewhere along the long wandering line of the vagus nerve, Vagus Vic rests in that particular way of his, not off, never off, but calm. The line is open, the signals are gentle. He is not calling anyone. He is simply making sure the connection holds. The way an old telephone operator might keep a hand near the switchboard without touching it. Ready, settled, present. The exocrine side of Pete, the ducts, the asana cells, all those stored and waiting enzymes, is as quiet as it gets. The zymogen granules are full and patient. Amylase Amy's pancreatic cousins are bundled in their inactive form, tucked away in their little storage pouches, not asked for yet, not needed yet. The duct moves the softest trickle of bicarbonate fluid, just enough to keep things ready. Not a flood, just a trace. The whole organ breathes in that kind of readiness. Not asleep, not working hard. Somewhere in between, which is, perhaps, the most intelligent place to be in the deep hours before morning. Pete knows this. The delta cells hold their quiet position in the eyelids. Somatostatin moves in its small local radius, keeping the neighborhood balanced. Not too much from the beta cells, not too much from the alpha cells. The middle is held. The middle is always held. It is a very small system doing a very large job. Around 1 million clusters of cells, scattered through the organ like lantern-lit villages on a dark plain. Each one monitoring, each one adjusting. Each one sending its small signal into the blood without fanfare, without acknowledgement. And the blood that flows through those eyelids flows on to the asana cells, carrying insulin with it. The same insulin that talks to the liver also talks to the enzyme makers, keeping them gently prepared for the morning that has not arrived yet. 1 signal, 2 conversations, the whole organ included. There is nothing to solve right now. There is nothing to fix. The breath moves in, the breath moves out. Pete is a soft, pale organ about 6 inches long. He weighs a little less than a peach. He lies crosswise and quiet, and he has been holding 2 jobs in one body for every moment of every night of every year without stopping. He asks very little. He gives an enormous amount. Most people will never think about him once. He is fine with that. The eyelids hold their gentle conversation. The liver listens at the other end of the line. The glucose moves in its slow golden current. The enzymes rest in their pouches. The duct keeps its trace of a trickle. The nerve stays open and calm, and the body sleeps on. Let the shoulders be heavy. Let the hands be warm. Let the breath do what it knows how to do. Pete is on watch. He has been here all along. He will be here when morning comes, steady, quiet, and already adjusting to whatever the day will ask of him. Pete knows this deep hour. The night is not over, but it is very, very settled now. Let the thoughts go where they want to go. You do not have to follow them. One drifts past, and then another, and then nothing at all. Somewhere behind the stomach, Pete rests in the dark. Not idle, never quite idle, but very, very still. The exocrine side is quiet. The asana cells have done their work. Their enzyme stores are full again, packed neatly into granules, waiting in a kind of soft suspension. Nothing is arriving from the intestine. No signal is calling. The ducts carry only the smallest trickle of fluid, just enough to keep the channels open, just enough to hold the readiness in place. Not a flood, just enough. And the islets, those small clusters scattered through the organ like lights in a darkened field, they have settled into their own deep rhythm too. The beta cells are still working. A low, steady pulse of insulin moving out into the blood. Not a response to anything in particular, just the baseline. Just Pete doing what Pete does, hour after hour, through the long dark. Liver Lisa heard the last signal some time ago. She adjusted, she always adjusts. Her glucose output is measured and calm, just enough to keep the blood supplied, just enough so the brain has what it needs. She would not describe it as a favor. It is simply the arrangement. It has always been the arrangement. We have order here. Glucose Gloria is moving through the bloodstream in a quiet, hexagonal way. Not too much, not too little. She drifts past cells, past capillaries, through the islets themselves. The beta cells note her presence. They adjust by almost nothing, a tiny fraction of a shift in output, too small to name. But it is enough. It is always enough. This is the thing about Pete's system. It does not need much to stay balanced. A small signal, a small response, a small correction, over and over, very slowly, all through the sleeping hours. The balance is not held by force. It is held by patience. Pete knows this. Vagus Vic is quiet on the line. His parasympathetic hum is low, and even the sound of a system at ease, not at attention. The cephalic phase is far away. No meal is coming. No signal of anticipation is moving through the nerve. He is simply present. The line is always open, even when no one is speaking. The delta cells hold their own gentle vigil. A small amount of somatostatin drifts between the islet cells, keeping everything moderate. Not allowing beta cells to overshoot, not allowing alpha cells to push too hard. Just a steady, neighboring kind of restraint. The islet keeps its own counsel. And the blood moves through. From the islets into the capillaries that serve the asana cells. Insulin in the current, small but real. The asana cells receive it. They stay ready. They do not activate. They do not release. They simply hold their enzyme stores and wait in a kind of warm suspension. Ready but resting. This is how a body spends a night well. Not by doing nothing, by doing everything at the lowest possible volume. By keeping every system just at the edge of readiness, without tipping over into action. It is a kind of maintenance that most people never think about, because it never asks for attention. It simply happens. Amylase amines, pancreatic cousins, are resting in their granules. The active form of amylase is there too, harmless, patient, in no hurry. Morning will come. There will be starch to meet, but not yet. Not yet. The duct cells sit along their branching channels in the dark. The bicarbonate they would normally produce in great volume through a day of eating, that production is nearly still. A trickle, a maintenance breath. The channels stay moist, the system stays primed. Nothing more is needed right now. Pete is perhaps 6 inches long, lying crosswise behind the stomach. He is not large. He does not announce himself. He has no particular drama to offer. What he has is constancy, the kind of constancy that does not require witness, that simply goes on whether anyone notices or not. Pete knows this deep hour. The head of the organ, heavy with asana tissue, holds its enzymes folded and locked. The tail, rich with islets, keeps its soft electrical murmur going. The two systems share their blood, their space, their quiet. And outside, in the body that holds all of this, the breath moves slowly in and out. The weight of the limbs has settled into the mattress. The room is dark. The mind has let go of most of what it was carrying. Everything is as it should be. Pete keeps working, softly, steadily, without being asked. Your arms are heavy. Your legs are heavy. That heaviness is the good kind, the kind that means the day is finally over. Steadily, without being asked, and so the night holds, not because anything is pushing it forward, not because anyone is watching. The night holds because this is what Pete does, hour after quiet hour, in the soft dark behind the stomach, where most people never think to look. The exocrine side rests. The asana cells sit full and still, their zymogen granules packed, their doors closed, waiting for a morning that has not yet arrived. The pancreatic duct carries only the faintest trickle, barely enough to call it movement. The whole digestive apparatus is folded inward, patient as a library after closing time. And the endocrine side keeps its watch. The islets of Langerhans, those roughly 1 million small communities, scattered through the organ like villages in quiet farmland, continue their local conversations. Beta cells release their low, steady signal. Delta cells hold the balance. The ratio of one hormone to another shifts by fractions, not by leaps. And liver Lisa, that tireless night manager 2 organs over, keeps responding. She releases glucose in careful, measured amounts, just enough, not more. Glucose Gloria moves through the blood in her unhurried loop. She is not piling up anywhere. She is not running short. She is simply present, the body's primary fuel, circling steadily, slipping into cells that need her, guided by Pete's quiet hand on the dial. Vagus Vic rests in his low hum. The parasympathetic tone is easy and slow. The gut-brain line is open, as it always is, but there is nothing urgent on the line. Just the ordinary music of a body at sleep. Pete knows this hour. He knows the way the body settles after midnight. He knows the way cortisol will begin its slow pre-morning rise before long, and he is already prepared for it, not scrambling, not rushing, simply ready. The beta cells will answer when the moment calls for it. They always do. For now, though, the moment calls for stillness. And Pete is very good at stillness. This is the part of the organ no one photographs. Not the dramatic spike of digestion, not the sharp response to a meal. This. The long, unhurried, extraordinarily competent quiet of a body doing exactly what it was made to do, in the dark, without a word of instruction from anyone. Pete knows this. While you sleep, Pancreas Pete is already at work. His beta cells are releasing their low, steady trickle of insulin, keeping liver Lisa's glucose output measured and smooth, so that the brain, which cannot wait, which does not store its own fuel, has exactly what it needs through every hour of the dark. His islets are reading the blood, adjusting by fractions, passing quiet signals to their neighbors. His exocrine side is restocking its enzyme stores in the dark, patient and unhurried, ready for the morning meal that has not yet been imagined. You don't have to do anything. Your body knows exactly what to do. It's been doing this work for your entire life, every single night. So let it, trust it. And as you drift deeper now, Pancreas Pete will be here when you wake up. Quieter, calmer, better, sleep well.